Integers are very important concept in math, and CubeMatic is an interactive tool for better understanding of integers. So this is the full view of it, and I'll get off some of the stuff that we are not going to need right away. So this is configurable. Okay, so we'll start with this. This is the simplest form. I have a container. This is what I call container A. And as you see, there are some spaces in it. And there are 9 spaces in here. And we'll see why we choose specifically 9 a little bit later on. And then I can put some stuff on it. What I mean by stuff is cubes. So this is first cube. And this is the second one, third one. I keep adding cubes like that. So once I have 9 cubes, then looks like there is no space here left. So I cover the entire container. But actually that's not the case. I can go further. So if I'll go to the 10th cube, then I need to go one up layer. So I'll start to use the second floor of the container. And if I'll do that again, once more, I'll switch back to the third layer. So actually there is no limit to that. I can go all the way up to sky. So let me go back. Right now I have 1 cube, and then if I'll remove that, no cube left. If I'll remove once more, I have a hole. So this is a new concept which leads us to negative integers, but I'll leave that to some other discussion. But just keep in mind that we have negative stuff there too. So let's put some stuff here. Actually, I can do it faster. So there are many stuff, but I don't know how many of those. So I need a counter. Let's fix that out. So we had 17 cubes there. So that 17 is important because we'll be using that a little bit later on for our regular way of doing integer arithmetic. Okay, so the next step is container S. Right now it has nothing in it. Let me clear that again. Put some few numbers there. So I have 2 cubes in A, and there is nothing in S. So nothing means there is 0 in S. And then I'll do step-by-step animation. So what I did, I'll take 1 cube in A, move that into S. And if I'll do the same thing again, and the last cube is moved in S. If I'll do once more, nothing happens. So go back and put some big numbers there. And then instead of going step by step as I did here, I can go, I can ask system to run that for me. So the important things to notice here is that the number of cubes in A are exactly copied into S. So we move 1 cube, put it in S. Move another cube, put it in S. We don't include any external cubes, or we don't drop out any cubes. Okay, so that's one important concept. Let me remove the, okay, let's say we reset that, remove the cubes, and then do the actually remove the templates too, and watch the animation with numbers. So this is the concept of addition. So we'll remove 1, we add 1. We remove 1, we add 1. We keep doing it till there's nothing left in A. All right? But in order to have addition, we need a second term. So let's get that. we put the templates and the cubes back. So I have 11 cubes here, nothing in B, nothing in S as we did at the beginning. So let's put some cubes in B. So, and then think about what to do with it. Would that be fine if I'll move all the cubes in B into S and then move all the cubes in A into S? So let's check that out. So we carry over the B's and then we'll move the cubes in A's and accumulate all that in S. So the result is that I have 0 in A, 0 in B, but 13 in S. Remember, we never lose or include any external cubes. So that 13 should be equivalent to the number of cubes in A and number of cubes in B at the beginning. Which is, let's check that out. I have 11 here, 2 here, 13 is the total number of cubes. All right? So one interesting thing that we can see right away is that what if I'll change 11 to 2 and 2 to 11? So I'll switch the positions of A and B. So initially I have 11 here and 2 here. Now I'll switch that out. So I have 2 here. I have 11 here. And then I'll do the addition again. I expect that the accumulated cubes will be exactly the same as the previous one. So switching the content of A and B would not make any difference in S. And this is an important property of addition. All right? So let's reset the system again. So A plus B equals S. So let's put that operation line here. So this is what we are doing. Okay, but in normal life, we don't have those cubes. We don't have those physical systems, but we do just numbers. So remove the cubes, keep the counters, remove the template or the container. And this is what we have. I have 2 in A and 11 in B and nothing in S at the beginning. And I'll run the system. And this is the addition. So B is completed, and then A is done. And the result is 13. All right. So far, we use no bases. So let's get the container and the cube back again. If I had many numbers in those, life would not be easy because I need to move 11 cubes in here and 20 cubes in there. In total, 31 cubes movement, which might took big time if I had very big numbers. Let's say consider I have 1,000,000 here, another 1,000,000 there, then I need to move 1,000,000 plus 1,000,000 moves, which is not easy. It will take too much time. So the question is, can I do better? The answer is yes. So let's clear that out. Put some small numbers here. Let's say 11 here. And then I'll change that to base 10 and get some more space here. All right. So this is how we represent the same number 11 in base 10. So don't see this part. Let me remove that to focus on what we have. Remove that too. All right. So I have position number 1, position number 2, position number 3. But instead of doing that way, we'll use the other way of doing it. So call this position 0, position 1, position 2, and those are the indices. And anything in here corresponds to 10 to 0, which is 1. And anything in position 1 means 10 to 1, which is 10. Anything in here will represent 10 to 2, or 10 squared, which is 100. So let's understand how we switch from 11 pile of 11 into this positional system. So here I have 1 times 1 plus 1 times 10, that makes 11. So let's increase that to 12. So I did my second cube here, 2 times 1 plus same 1 times 100. And let's put some more stuff here. So now be careful, I have 19. So 9 times 1 plus 1 times 10. And then the question is this, what happens if I increase this by 1? So if that becomes 10. Remember, in positional number system, there is one rule. You are not allowed to go to the second floor. And for 10, I need to go 1 up, which is not allowed. So let's try to see what's going to happen. So I'll increase from 9 to 10, and suddenly this becomes 0, and that 10, all those 10 cubes are moving to the first layer from the 0th layer. So this is how we read it. 0 times 1, which is 0, plus 2 times 10, which is 20. So that's a little bit complicated, so let's make it easier. So right now I have nothing. I put 9 here. So I have 9 boxes. And then put one more to make it 9 cubes. Oops, sorry. No, that was a mistake. I need to restart. Okay, so now I'm going to add one more. So whenever I add one more, it moves to here in the 10th position and nothing left in the 0th position. Right? So if I'll take ones off, again, I'll move that 10 back to here and remove one cube, and the 9 is left. All right? So the same thing goes with 100. So nothing here, 0 times 1, 0 times 10, and 1 times 100. So this is the 100. If I add 1, remember, ones are always in this position. So I increase that by 1. So let's add some more stuff. So now I have 2 here times 1, 1 times 10, 1 times 100, which makes 112. So okay, now remember, I promised you to faster addition. So get B and S back, get the addition line to make it proper. So let's say I have 112, and I want to add, let's say, 1 to it. Okay, so let's start the animation and count the number of moves. 1, 2, 3, 4, 5. So within 5 moves, I do the addition. And let's remember, if we were to do it in the pile system with no base, I have to move 112 moves here and plus one more 113 moves to make the summation. So base 10 is much faster, way faster. Remember, 1, 2, 3, 4, 5 moves, and I'm done. Okay. Let me show you one more thing for the future references. So again, go back to the no base system, and suppose I have one hole, and suppose I have nothing here. So if I'll do the addition, that hole moves down to S, and we are done, right? Okay. So what happens if I have one box here, one hole here, What is the addition of it? An estimation. So let's run and see. So one hole plus one box will cancel out each other, and we'll have 0 in S, nothing left. And that will be discussed later on. I think I should be stopping here. So you are quite welcome to play with this interactive tool in 01pi.com, which is available for you to investigate further. Thank you.